Welcome to Maths Academy Tube. This is a video lesson on application of integral calculus. The application of integral calculus is very wide. So in this video, I will focus only on finding the areas and volume of certain objects using integration. So before I proceed to problem solving, here on the screen, you can see the formula to calculate the area and the volume of a certain objects. Okay, so the first formula is about the formula for the area of a certain region, which is bounded by two functions f and g, where these two functions are continuous on a certain closed interval. So we use this formula to calculate the area of a certain region bounded by two curves f and g. The second formula is about the formula for the volume of a certain object. So the volume V of a solid of revolution generated by revolving the region bounded by f and g, where f is greater than or equals to g for every x in a certain closed interval AB. So if we have such conditions, the volume of a solid can be calculated by this formula. So you need to have these formulas to understand the problems that I have next. So let's see the problems. The first one is if the volume of the solid which is generated when the region bounded by y is equals to radical x plus 1 about the x-axis from 0 to x is equals to 0 to x is equals to 2. So we are asking the volume of a certain object which is generated by revolving or rotating a certain function f here that you can see y is equals to radical x plus 1. We consider the region from x is equals to 0 to x is equals to 2. So we have a certain formula. The volume of such solid object will be obtained by the formula, the integral from 0 to 2 pi times f of x the whole square. Okay, so we calculate this definite integral from 0 up to 2 pi times our f of x is radical x plus 1 the whole square dx. So this becomes pi times the integral from 0 up to 2 the square of radical x plus 1 means x plus 1 dx. So this means pi times the integral of x is x squared over 2 and the integral of 1 is x. We evaluate this expression between 0 and 2. So first substitute 2, then when we substitute 2 it becomes 2 squared over 2 plus 2. Then substitute 0 in place of x, 0 squared over 2 plus 0. Okay, the whole this thing is 0, so this will be 0. So this is pi into 2 squared over 2 means 2 plus 2. 2 plus 2 is 4. 4 times pi is 4 pi. Therefore, the volume of this solid object generated by revolving y is equals to radical x plus 1 in the given interval is 4 pi. Therefore, our answer for this problem is A. What is the area of the region between the graph of y is equals to x squared and y is equals to minus x plus 2? We have two curves, or we have two functions where x is considered from 0 to 2. So the question here is the area between the two curves, y is equals to x squared and the line y is equals to minus x plus 2. So to find the area between these two curves from 0 to 2, it's good to sketch the graph of the functions in the xy plane. So here here we have the graph of y is equals to x squared. Okay, here we have y is equals to x squared, which is a parabola. Okay, this one is the upper parabola, is the graph of y is equals to x squared, whose vertex is at the origin, and the straight line y is equals to minus x plus 2 is another given function. So the question is, we are asking the area between the two curves from x is equals to 0, here up to the point 2. So when we see the region between the two curves, we can find two different regions. Call it this the first region A1, and if you call this the second region A2. So we consider the area from 0 to 2. So the area for this region will be the integral from 0 to 2, but these two regions are separate, so we consider from 0 to 1 and from 1 to 2, where this 1 is the intersection point of the two functions, y is equals to x squared and y is equals to minus x plus 2. Now our function f is the difference between the two. Okay, our function f is the difference between the two. In the first region from 0 to 1, the line y is equals to minus x plus 2 is above the y is equals to x squared, so minus x plus 2 minus x squared will be considered for the first region, and in the second region we calculate from 1 to 2, then x squared minus x plus 2 dx. So let us calculate these integrals. So this is for the first integral, we have minus x squared over 2 plus 2x minus x cubed over 3. We evaluate this integral from 0 to 1. And for the second part, we have x cubed over 3 plus x squared over 2. You can distribute this negative into the bracket. Then minus 2x. Again, we evaluate this integral from 1 up to 2. So here substitute 1. Then you will get minus 1 over 2 plus 2 minus 1 over 3. But when we substitute 0, the whole this thing becomes 0, so that is meaningless. Then when we go to the second bracket, we substitute 2 first, then 2 cubed, which is 8 over 3, plus 2 squared is 4 over 2, minus 2 times 2 is 4, minus substitute 1 over 3, plus 1 over 2 minus 2. Then let us evaluate all this thing. Minus 1 over 2 plus 2 minus 1 over 3 plus 8 over 3 plus this is 2 minus 4 minus 1 over 3 minus 1 over 2 plus 2. So here we can simplify things. 2 plus 2 is 4. We have minus 4, therefore all these things becomes eliminated. The other thing is here, let us rewrite the things. So we have minus 1 over 2 minus 1 over 3 plus 8 over 3 minus 1 over 3 minus 1 over 2 plus 2. So adding all this thing will gives us 3, as you can check. Therefore the area between these two curves is 3. Our answer will be 3. Okay, So our answer will be A. The next problem is what is the area of the region between the graph of y is equals to sin x and the x-axis, where x is from 0 up to 2 pi. Similarly, here we need to know the graph of the sine function. We need to know the graph of a sine function. Usually the graph of a sine function looks like this. It looks like this, passing through the origin, and 0 up to 2 pi means one complete cycle. Okay, here 0, here 2 pi, but between 0 and 2 pi we have another x-intercept pi. So we are asking the area between the x-axis and the graph of sin x. So we are asking this small shaded part. So it's very simple to calculate the area of such region. Simply use the formula A is equals to the integral from 0 up to 2 pi of sin x, but this sin x have different region. One of the region is this one, the other region is this one. So this integral can be calculated by 0 up to pi, that means the first region, sin x dx, plus the second one is the absolute value of pi up to 2 pi sin x, because we need to apply absolute value to avoid the negatives. Area will not be negative. So this means minus cos x is the integral of sin x. We evaluate this thing from 0 up to pi, plus again in the bracket we will have minus cos x. We evaluate this thing from pi up to 2 pi, but this term should be in the absolute value. It should be in the absolute value. So let us calculate the things. The negative of cos pi minus cos 0, plus in the absolute value we will have the negative of cos 2 pi, the negative of cos 2 pi minus cos pi. Okay, this is in the absolute value. So cos pi is negative 1 and cos 0 is 1, plus in the absolute value cos 2 pi is negative 1 and cos pi is negative 1. So we evaluate this thing. Therefore this is negative 2 by negative, it becomes positive 2, plus this is also 2, absolute value of minus 2 will be positive 2. Therefore the area for this region will be 4 square unit. So our answer for this problem will be A. The volume of the solid generated when the region bounded between the graph of y is equals to x squared for x between 0 and 2, and y is equals to 4 for x between 2 up to 3, in the x-axis. We are asking the volume of a region, the volume of a solid generated by this function and the x-axis. So here we need to know the formula for the volume of an object generated by a certain function from a to b, times pi times f of x the whole square dx. This is the formula for the volume of a solid generated by the function f revolving on the x-axis. So the function is given from 0 up to 3 totally, f of x the whole square dx, but this function is different from 0 up to 2 and from 2 up to 3. So we evaluate the integral from 0 up to 2 times pi f of x is x squared in this interval. Our function is x squared in this interval. We square it, and from 2 up to 3, the function is 4. As you can see here, the function is 4. We take it the square of this function. So this is very simple calculation, pi into the integral from 0 up to 2 x to the power of 4 dx plus pi into the integral from 2 up to 3, 16 dx. Now this becomes pi into x to the power of 5. X to the power of 5 over 5 is the integral of x to the power of 4. This will be evaluated from 0 up to 2 plus pi into the integral of 16 is 16x. This will be evaluated from 2 up to 3. Now substitute 2 in the first expression. 2 to the power of 5 over 5 minus pi into 0 to the power of 5 over 5 plus, again let's come to the next term, pi times 16 times 3, substitute 3 first, then pi times 16 times 2. Now this becomes 0, and 2 to the power of 5 is 32, so this is 32 over 5 pi plus, this is 48, and this one is 32. 48 minus 32 is 16 pi. Then adding these two together gives us 32 pi plus, you can crisscross it, it becomes 80 pi over 5. This means 112 pi over 5 will be the volume of the object that we can get here. So our answer will be B. What is the value of the area of the region enclosed by the graph of y is equals to e to the power of x and y is equals to x between minus x, x is equals to minus 1 and x is equals to 1. So we need to apply the formula for the volume, the area between the two curves from minus 1 up to 1, but the functions are e to the power of x and x. Okay, these are our function. So sometimes if you are not using the graph, you need to sense what it looks like, but the integral of this one is e to the power of x minus x square over 2. We evaluate this thing from minus 1 up to 1. So first substitute 1, e to the power of 1 minus 1 over 1 square over 2. Then substitute minus 1, e to the power of minus 1 minus minus 1 square over 2. So this becomes e minus 1 over 2 minus 1 over e minus 1 over 2, which is e minus 1 over 2 minus 1 over e plus 1 over 2. So this is 0. The result is e minus 1 over e, which is e square minus 1 over e. So we can find this one or this one from the given alternative. Therefore our answer is this one. Okay, which of the following is equal to the volume of the solid generated when the region bounded by the graph of y is equals to 2 times radical x plus 1, and the interval in which x is considered is 0 up to 2. So as usual, the only thing that you need to have is the formula for the volume of an object generated by revolving the function y is equals to 2 times radical x plus 1 from x is considered from 0 up to 2. This is pi times f of x the whole square dx. It's very simple. So this becomes pi into 0 up to 2. F of x the whole square means 2 radical x plus 1 the whole square dx. This becomes pi into 0 up to 2, 4 into x plus 1 dx. 4 can be taken out from the integral. Then we will evaluate the integral of x plus 1 from 0 up to 2 and multiply by 4. So this becomes 4 pi into x squared over 2 is the integral of x. The integral of 1 is x. We evaluate this thing from 0 up to 2. First substitute 2, then 4 pi into 2 square is 4. 2 square over 2 plus 2 minus 4 pi times 0 square over 2 plus 0. So the whole this thing becomes 0. Then this becomes 4 pi into 2 square is 4. 4 over 2 is 2. 2 plus 2, which is 4. 4 times 4 is 16 pi. So the volume of this object is 16 pi. A particle along the x-axis with velocity is given by v of t is equals to 3t squared plus 6t for positive time t. If the particle is at the position x is equals to 2 whenever t is 0, what is the position of the particle at t is equals to 1? So here, to answer this thing, we need to know the relation between the velocity and position of the particle. So we know that the position of a particle at a time t can be calculated by the integral of the velocity of the particle, or the velocity of the particle at a time t is the rate of change of the position of the particle at a time t. So for now we have the velocity of the particle, which is 3t squared plus 6t dt. As usual, there is a constant of integration c. So the integral of 3t squared is t cubed, and the integral of 6t is 3t squared, as you can check, plus c. This is the position of the particle at a time t. So to determine c, we have the position of the particle at t is equals to 0 is given by 2. Already it is given here. Initially the particle is at a position 2 whenever t is 0. So this information gives us x of 0 is equals to 2 implies x of 0 means 0 cubed plus 3 times 0 squared plus c, which is 2. So from this thing we understand that the whole this thing is 0, therefore c must be 2. So the position of the particle now is completely determined, which is t cubed plus 3t squared plus c, which is 2. Now we have the position of the particle at a time t. The question is, what is the position of the particle whenever t is 1? So evaluate x of 1, which is 1 cubed plus 3 times 1 square plus 2. So this is 1 plus 3 plus 2. Therefore, our answer is 6. So the answer for this problem is 6. What is the area of the region bounded by the lines x is equals to 0, x is equals to 2, y is equals to 1? So to understand this problem, it's good to sketch the graph. So x is equals to 0 is the y-axis, x is equals to 2 is a vertical line like this, okay? So assume this is x is equals to 2, this is x is equals to 0. The other thing, y is equals to 1 is also given. Say this is y is equals to 1, okay? So the other thing is y is equals to e the power of 2x. It's like this, it's exponential. It will have this form. We are asked the area of the region between these 4 curves. The area of this, we are asked here, this thing only. So to calculate this area, we need to understand the boundaries. The area is from 0 up to x, from 0 up to 2, okay? And it's bounded above by y is equals to 1 minus, and it's bounded below by y is equals to e the power of 2x. We evaluate this thing. So this becomes the integral from 0 up to, this is very simple. The integral of 1 is x, and the integral of e the power of 2x is half of e the power of 2x. We evaluate this thing from 0 up to 2. So first substitute 2 minus 1 over 2 is a power of 4, because x is 2 here, minus substitute 0 minus 1 over 2 is a power of 0. Then this becomes 2 minus e the power of 4 over 2 minus of 0 is 0. Then this becomes plus 1 over 2. E the power of 0 is 1. So this becomes 2 plus 1 over 2 minus e the power of 4 over 2, which is 5 over 2 minus e the power of 4 over 2. So this is the given area here. So our answer will be B, okay? If the region enclosed by the graph of f of x is equals to x squared and f of x is equals to x cubed for x from 0 to 1 rotates about the x-axis, what is the volume of the solid of revolution obtained by revolving these curves? So as usual, we need to know the formula for the volume of a solid obtained by revolving the 2 curves, and the interval is from 0 up to 1. And obviously these 2 functions, x squared and x cubed, are continuous. So the formula for the volume obtained by revolving these 2 curves is pi times the square of their difference, f of x squared minus g of x squared dx. So we can directly substitute the functions. Pi into x squared means, f of x means x squared, then we take it the squared values minus g of x is x cubed, and we square it. Then we take the integral from 0 to 1. So here we can take it out, the constants. Pi can be taken out from 0 up to 1. X squared means the square of x squared is x to the power of 4. The square of x cubed is x to the power of 6 dx. Now the integral of x to the power of 4 is x to the power of 4 is x to the power of 5 over 5, and the integral of x to the power of 6 is x to the power of 7 over 7, and we evaluate this expression between 0 and 1. So first substitute 1 in the expression. When we substitute 1 in place of x, we can get 1 to the power of 5 over 5 minus 1 to the power of 7 over 7 minus, now substitute 0, then 0 to the power of 5 over 5 minus 0 to the power of 7 over 7. So these terms are 0. So we evaluate only this part, which is pi times 1 over 5 minus 1 over 7. Here this is pi into 7 minus 5 over 35, which is 2 pi over 35. Therefore, the volume of the solid obtained by revolving the function f of x is equals to x squared and f of x is equals to x cubed for x between 0 and 1 is 2 pi over 35. Therefore, our answer will be D.